Welcome to Intel Innovation 2021, and I'm thrilled to have you join us here today, live. Well, sort of. I wish we could all be together in person, but not quite yet, so hopefully soon. Today, we are going to take you on a journey from silicon to superpowers. The geek is back at Intel. Today, we're going to look at how the technology superpowers fundamentally alter how we experience technology. We'll look at how you, developers, can harness these superpowers and bring them to life in your creations. Each is impressive on their own, and together, the superpowers reinforce and amplify one another. This allows us to push forward with innovation, discovery, and disruption. As these technologies accelerate, developers, technologists have an increasing greater impact on defining this new era. But what are these superpowers I'm talking about? These superpowers that are at the heart of industry shaping digital transformation. First, ubiquitous compute. Second, cloud-to-edge infrastructure. Third, pervasive connectivity and AI. Ubiquitous compute is where humans interact with the ever-changing faces of technology. Cloud-to-edge infrastructure provides a scalable solution to process the plethora of data while addressing demands for lower latency and higher bandwidth at the edge. Pervasive connectivity allows technology to communicate with everyone and everything, and AI bringing intelligence to all of it. Today's developers are discovering leading-edge concepts and creating the future. Through the developer community, we are entering a renewed era of innovation. It's all about you, the developers, software and hardware. Our recent actions in the ecosystem must be built on core values that are essential to you, but we haven't done a great job recently. We need to stay connected with you through the evolution of that ecosystem. Today, this changes. We can and we will do better. Today, we are recommitting to delivering what you expect and need from us. A complete portfolio of hardware, software, tools, technologies, and products for developers. Let me be clear, Intel's commitment to you is a developer-first approach. We're going to pin our strategy on three things. First, open. Like we opened up our fabs earlier this year, we're unlocking the garden gates for developers. Second, choice. We are designing for multi-vendor, multi-cloud, silicon, platform, software solutions so you get the most ubiquitous, stable, reliable platform for running modern applications. And third, trust. We have your best interest as a developer at heart, and we will deliver solutions with world-leading security features anchored to product truth. No gimmicks, no marketing fluff, just geeky goodness.
Hey, Pat.
Hey, Greg. How are you, my friend?
All right, thanks. Hey, I bought a t-shirt I wanted to show you today. It's basically, I have a collection of math geek t-shirts that keep me grounded in physical reality. And this one is a play on Einstein's famous equation, E = mc squared. Is you matter, but if you multiply yourself by the speed of light squared, you become energy. The way I interpret this is that hardware tames the physics, the transistors, the electrons, and the photons. Software tames the hardware. But the two together are a force multiplier that makes humans more productive and conserves human energy. And as someone once said, software is the soul of the machine.
Well, geeky energy, it's what it's all about. Thank you, Greg. And Greg, as our CTO and our head of software, what are we going to do for developers?
Well, you're right, Pat. We got to do a much better job of just communicating all the things that we've done and the things that we have available for developers. We've been overly quiet about all that. So we have a tremendous amount of software technology that Intel already offers developers, and more is in the oven being developed. In fact, today we're announcing Intel Developer Zone. Previously, there were multiple dev portals, web portals, dev clouds, and resource repositories spread across Intel's web properties.
Way too much complexity.
And hard to find things. We've streamlined everything into one location, and this updated unified Intel Developer Zone is where you can provide access to a software catalog that has over 400 software tools, SDKs, and libraries available in an improved dev cloud environment that has our latest technology in it, so that you can basically build and run your applications and test out on our most recent hardware and accelerated software tools. And this is just the first step. We're going to continue to build on this and continue to expand it to make it a first-class repository of key technology.
Yeah, and many in the audience are really looking forward to being able to access the coolest stuff, the most leading edge, but they also need to make it work with the legacy environments. And this is exactly what OneAPI is out to solve for us. Can you give us an update on how OneAPI is doing?
Sure, Pat. Today we're announcing OneAPI 2022 to be released in December. It's a collection of 7 distinct development environments with over 40 different technologies to enhance productivity. We've added over 900 features in the last year. 900 features, over 900 features since OneAPI 2021 and shipped last year, including expanded cross-architecture development tools and environments, advanced cross-architecture analysis with accelerator performance, modeling, and we've added flame graphs to vTune Performance Analyzer to find those hotspots. And if you're using Windows, you're developing on Windows with Visual Studio, we take advantage of the Windows subsystem for Linux version 2, which allows you to install a complete distro of Linux, take your favorite one, into the Windows environment and do development in Visual Studio and deploy and run in a dual environment on your Windows laptop. And we've made enhancements to data parallel Python, adding accelerators and bindings to OneAPI performance libraries so that developers get more power out of their Python development environments.
And OneAPI is more than just a set of standards-based software for Intel platforms. It's much bigger than that.
Yeah, absolutely. So it's a full open source set of resources, libraries, runtimes, SDKs, and applications that are being developed across the industry using OneAPI tools and technologies. So if you go to developer.intel.com, you'll find that whole set of accelerator tools. We've seen considerable momentum over the last year with industry libraries, particularly for data parallel C++ using the SYCL extensions that allow you to work on multiple platforms, CPUs, GPUs, and FPGAs, to name just a few. And so we want to provide an open ecosystem and open support for the whole industry and break the proprietary lock-in of certain software technologies.
Yeah, so clearly open and open source. And it's a good thing that we're expanding our OneAPI centers of excellence. In fact, today we're announcing 11 more institutions of research, higher learning that are coming around the OneAPI initiative to give us more training, more partners, help drive more understanding in the industry, create a broader community of capabilities around OneAPI. And we're looking forward to having a lot more institutions join the OneAPI Centers of Excellence program.
The open source community is really the source of a tremendous amount of innovation, so we're not the only ones producing that innovation. We're going to leverage it. And so the components that we've added to Intel OneAPI expose all these cutting-edge features of our latest hardware, so you can get more from your CPUs and your XPUs. Major improvements in our whole LLVM-based compiler system. I already mentioned support for SYCL with data parallel C++, but many, many other enhancements in that environment. And great breakthroughs in our Intel Deep Neural Network library to give you high performance for AI and ML applications. And we've done a lot of work as well to continue to speed up our cryptographic library so that if you adopt it, as OpenSSL has, you get the great accelerations that we have on our hardware for cryptographic algorithms. We're also committed to a developer-first approach, one based on openness, as you said earlier, choice, and trust. Of course, simply hearing this from me doesn't necessarily convince you, so we went to talk to some of the most renowned people in the development community to ask them for their thoughts.
Let's hear from them.
Development's changed a lot in the last few years. For example, a lot of innovation just comes straight from open source communities, so that means developers have access to a lot of technology, but that doesn't mean they necessarily have the time to become experts in all those technologies.
Anyone who's trying to support the developer ecosystem should understand this desire for openness, this desire for collaboration, this different way of thinking than perhaps we all learned when we learned like Adam Smith's invisible hand and all that, right?
AI is really a blossoming field, but it's also a very nascent field. Developers are part of the democratization of the technology.
People are collaborating together on these big problems, doing more than any one person or one company could do alone. And it's that iterative process of building on each other's great ideas that really develops this velocity, this really great momentum.
The work of the developer has changed from just writing a feature and forgetting about things to really what we call shift left, where the developer is thinking about, will this deploy successfully? Am I doing all the right things? Is this going to end up leading to security issues? Am I going to take up too many compute resources?
Intel is an extremely relevant player, but in the past 10 years in the deep learning revolution, the traditional image of Intel being a leading technological player has been slipping quite a bit.
As the hardware evolves, we haven't seen that same level of deep engagement, which means it's difficult to consume the technology as a development community when you're not notified early in the process, or you look at ways to deliver technology outside of the core upstream projects.
It's not that there have been big breaches of trust, things were offered, taken away, that kind of thing, but rather more of a, oh, maybe we are not a priority.
I'm very excited that in a way, with a relief that Intel is finally re-engaging and thinking about all this.
We need Intel's expertise as we foray into these new frontiers of multiple types of workloads, portability, and also as we start exploring parallelism, where you have to get really complex and the GPU matters.
All these forces are creating an exciting future for more technological innovations in the space.
Communities can't manage pre-baked ideas without having some input. So it's not just the, here's our ideas, work with us on them, but it's, here's the concepts behind our ideas. What's the best way to build those together? And I think that's a fairly fundamental change. If we see that in the community, we'll really see that velocity and that innovation engine take off.
It's so exciting to hear from folks like Chris, Fei-Fei, and Priyanka. Clearly, we've got some work to do. As author Thomas Friedman has noted, the world is fast, fused, and deep, and we're moving at a faster pace than ever before. Everyone and everything is becoming interconnected, and deep learning is permeating throughout it all. The things that absolutely wow us today will be table stakes tomorrow. This year marks the 50th anniversary of the 4004 chip. Think of how much we've accomplished in the past half century, 50 years. This is like a sacred moment for technology. This is what made computing really take off. Now, I recently had the opportunity to chat with one of our founders, one of my heroes and mentors, Gordon Moore. It was an amazing trip down memory lane, and we'll share more of that conversation later. But first, let's take a look at what he had to say about this historic milestone.
First, Gordon, I want to tell you how excited I am to be able to chat with you today. In November, we have the 50th anniversary of the 4004, the first general purpose microprocessor. And maybe you can describe the opportunity that you and Bob Noyce saw for the 4004 when we first created it.
One of the things that was being considered those days was calculators. Everybody wanted an electronic calculator. So we got introduced to a Japanese calculator company. This was the tail end. We were Johnny-come-lately to the semiconductor business. And they were in a similar position than calculators. But anyhow, we decided this was a good opportunity. And we took a look at what they had done. And they had done the logic design for several different kinds of calculators. These were multifunctional things. And they wanted something like 13 complex circuits. And one of our engineers, Ted Hoff, came from the systems end of things. And after we were lamenting the fact we weren't big enough to tackle 2 chips, let alone 13, he said, I think I could do all these functions with a general purpose computer architecture. And it shouldn't be much more complex than the memory chips you're making now. We were making 1024-bit MOS devices, 6 transistors per bit, so about 6,000 transistors on a chip. Now, this was attractive to me because it gave us something we could make in the large volume, and it was broadly applicable. All of these 13 chips could be replaced by a central processor and a couple of memories, which were standard products. So this looked like another branch beyond semiconductor memory where we could take advantage of the developing technology's capability.
A 4-bit CPU that clocked at a whopping 740 kilohertz to today, a chip with 16 cores, 24 threads, and 5.2 gigahertz and turbo frequency. Semiconductors are the underlying technology that's empowering developers and powering our customers' innovations. And here's where it started. I just mentioned the 4004, and a year later, the famous 8008 came out. So I thought that would be a good place to start. Because while it was neat to look forward and think about what my grandkids will grow up with, it is also amazing to think about how far we have come. Intel started out fabricating these small polysilicon transistors. Well, they felt small at the time, and then we made them even smaller. This is when I joined Intel, by the way. Here was the basis of the computer revolution. The insatiable demand for computing performance drove us harder. Us includes me and my first design team here. We changed laser sources so we could print with even shorter wavelengths of light, metal interconnects with higher mobility, adding more and more layers on top, innovating with new material science, strained silicon, high-K dielectrics, and replacement with metal gates. And then we introduced the FinFET. By this point, the classic gate length node naming was broken. There was no single structure that measured that length anymore. As we refined the FinFET design, node numbering became even less relevant, less meaningful. Performance now comes from more than just transistor dimensions. Yes, we are printing them even smaller, but it also comes from different types of transistors optimized for different types of needs and put together in architectures that are tailored for software workload needs. So let's take a look at the next major innovations that we're up to. And let's look at it here. And the idea is the RibbonFET. And in Intel 20A, we are introducing the next major step in transistor technology. And if you look at this here, what we're able to do is we're separating the gate from the underlying silicon, giving us this gate-all-around effect. Then this allows us to have a reduction in leakage current, improving in a smaller footprint over the FinFET, today's leading-edge capabilities. And, right, if you look at this, we're able to design with higher and thicker sizes in the ribbons, which give us more power, but we can also design them with more and thinner structures as well for lower leakage, lower power usages as well, where we might have 2, 3, or 4 of these ribbons, giving us different sizes of transistors. Of course, we're continuing to think about how we put these together, and any CMOS designer knows that you have both NMOS and CMOS transistors side by side. That's what it means by complementary MOS. We have both N and P. But our teams are working on what comes after RibbonFET, and with that we have this idea of let's stack them on top of each other. And this allows us to further reduce the area, and it also reduces the parasitics since we don't have to connect the two together and have contacts and metal between the two, bringing those together. A major breakthrough in how we think about the next generation, even beyond RibbonFET. But of course, we're doing some other cool innovations as well. And one of the other challenges that you have in designing leading edge circuits is power, right? And how do you get power to the devices and power out of the devices? And this is where Power Via comes in. And this is taking the power grid and moving it under the transistors. And this creates this whole separate power delivery from signal routing for increased performance. And taken together, Moore's Law is alive and well. Today we are predicting that we will maintain or even go faster than Moore's Law for the next decade. Wow, what a profound and bold statement. How can I say that? Well, with EUV, we have a clean path of lithography, and lithography always been the heart of semiconductor innovation. With RibbonFET, we have a clear path for sustained transistor improvements. With PowerVia, a clean path for power delivery and management technologies. And most importantly, packaging. Packaging is now leveraging silicon processes. Even Gordon understood the importance of packaging and said as much in his original paper. Multi-tiles will allow us to solve reticle size limits and defect density challenges, 2D, 2.5D, and 3D stacking, and packaging for increased effective transistor density for system on package. We are entering a period of sustained, if not super Moore's Law. We expect to even bend the curve faster than a doubling every 2 years. And we will not rest until the periodic table is exhausted. We, as the stewards of Moore's Law, will be relentless in our path to innovate in the magic of silicon. Like I said, Moore's Law alive and very well. As we've spoken about at length this year, we're expanding our at-scale manufacturing of semis globally to help address the insatiable demand and need for compute. We are also working to develop a broad set of IP blocks with leading third-party suppliers to enable customer tape-outs and production in 2022 from our Intel Foundry services. And we're seeing a great deal of industry interest in our leading packaging technologies, which as we've said, are increasingly important as we move to more modular designs with blocks that we call chiplets in the industry or tiles. And we are also initiating an effort with the industry to create an open chiplet ecosystem, starting with a standard interconnect based on CXL. This will enable new customer and partner solutions working seamlessly on both current and future products and platforms. More on this standards effort in the future. Overall, our commitment to global supply and capacity in a distributed and more resilient fashion. We need a globally balanced, resilient supply chain. This commitment is unwavering, and we're just getting started. So, with that, let's dive into the superpowers. Team.
Pat.
Hey, Pat. Let's start with Ubiquitous Compute. And each one of us will soon have thousands of devices that are at our immediate disposal. By the end of this decade, there will be, every human to have one petaflop of compute, 1 petabyte of data within 1 millisecond away.
We tend to forget what a petaflop is. That's 10 to the power of 15, or 1,000 million operations per second. And then a millisecond, we tend to forget what you can do in a millisecond too. So in a millisecond, light can travel 1 million feet, which means if we can put that petaflop within 100 miles of a user, we're going to meet that goal.
Well, and if you think about a millisecond as well, it's one of those magic thresholds where everything is real time if you're less than a millisecond.
Oh, wow, that's really the definition of ubiquitous computing, right? Of course, when I think about ubiquitous computing, I can't help but think about the PC. The PCs are all around us. And Andy Grove once famously called the PC the ultimate Darwinian device because it continued to evolve and transform and adapt, and it's become even more essential. Couldn't be truer than that is today. And we've got some exciting announcements I'd like to make around the PC. The PC is one of the most innovative and open platforms ever invented. And we want to equip you, the developers, with the tools and the technologies that make it easier to develop and create experiences to shape the future. With that, I'm pleased to announce today that we're launching a series of Linux-based workstation-grade PCs powered by Intel Core and Xeon processors that come with a pre-configured data science solution. Now that data science solution includes the One API AI Analytics Toolkit, which accelerates software up to 100 times for training and inference. It has 3 times the memory configurations of competitive offerings with Intel Optane memory. And it has the accessible and kind of ubiquitous AI acceleration with our AVX 512 instruction sets. Put together, it's a seamless, easy-to-use solution enabling data scientists to iterate, visualize, and analyze complex data at scale. And speaking of openness and choice in the ecosystem, which is a big theme today, all 3 of our leading OEMs, Dell, HP, Lenovo, they're all offering numerous designs featuring this solution. And as more developers are becoming data scientists, they've also been requesting Windows, which is why we reached out to our friends at Microsoft to see what we could enable together. And I'm pleased to have with me today to share more Microsoft's Executive Vice President and Chief Product Officer, Panos Panay. Hey, Panos, good to see you. Yeah, thanks for joining us.
Are you kidding? I couldn't be more pumped to be here. Microsoft Intel partnership, truly amazing.
That's right, it is. And we have this long, deep partnership, and it's why we turn to you at Microsoft to really help us improve the experience for developers.
Look, at Microsoft, we talk about it all the time. With Intel, we talk about customer-centered design. GB, we do this all the time. Now, Windows 11, it's just a beautiful example of that. I mean, it's a platform for platform creators, and as I listen to right now what Intel's announcing, the tools we've created with Intel on Windows 11, it just simply empowers devs, and when you talk about focus on customer, devs, to build and innovate for their own customers themselves.
No, and that's right, and that's why you came out today. And with our partnership and deep collaboration, we're excited together to announce that we're bringing a complete data science tool chain to Windows and to developers.
Yeah, and it's coming to data scientists and developers, right, globally. And it's coming on this product right here. I love this product. This is the new Surface Laptop Studio. It's got the Intel processor, 32 gigabytes of RAM, fully immersive audio, new versatile, pixel sense display, discrete graphics. Like, this is a product, and of course the two Thunderbolt ports.
Yeah.
I know,
Fantastic.
you love those.
I like it.
But best of all, you have a developer class workstation with the portability of a laptop. And I think that's where transformation starts to happen. Windows 11 brings support for GPU. We're talking about accelerated ML training, WSL2, Windows Terminal, seamless integration with Visual Studio, VS Code. Power Toys lets developers customize their workflow for maximum productivity. Like, this is the most efficient setup for coding that I believe there's ever been. And this is just the start. And whether you're a Windows app developer, a cloud service, or full stack web developer, a data scientist, right, when we talk about focusing on the customer, we've absolutely got you covered.
No, that's awesome. It's just incredible. You just pack so much in there. And of course, you can expect to see more OEMs and systems delivering this kind of configuration for developers in the coming months. It's all about openness and choice, which is just fantastic.
Yeah, and there's also a huge opportunity here, GB. Think about for developers to reach customers through the scale of Windows, and we do this in a whole new way in the Microsoft Store with Intel Bridge technology. I know.
Oh, that's right. You said Intel Bridge technology. I love it. For the first time ever, we work together to help bring Android applications into Windows.
And it's super cool. It's all about making the Microsoft Store more open for you, more accessible for developers and your customers.
No, that's right. It's a win-win-win for everyone involved, and we're really excited to announce that this is now available from you as part of the Insider program, and there's a QR code on the screen today for you guys to go out and check
Get on it. Get on it. It's awesome.
Thanks for joining me today, Panos. I really appreciate
it. Thanks, GB.
All right. Well, Intel and Microsoft have partnered together for a long time, for decades, to bring innovation to the PC platform. And of course, for us at Intel, that innovation all starts with the heart of the PC experience, which is the CPU. So today, we're excited to launch our 12th gen Intel Core family of desktop processors. This is the first family of processors built on our Intel 7 process node. It's headlined by the unlocked Intel Core i9 12900K processor. I have it here in my hand. It's the world's best gaming processor. But it's more than that. It's more than just a gaming processor. It delivers the best overclocking experience and has a ton of industry-first features like DDR5 memory support, PCI Express 5.0 support up to 16 lanes, and the launch of the desktop processor is just the beginning. The entire 12th generation Core family is going to include 60 different processors that'll power more than 500 designs from high-performance desktops to ultra-thin and light laptops. Now we're already shipping 28 versions, 28 SKUs to our OEM partners around the world in production, and we're launching our first processors here live today at Intel On. In addition, we're going to begin shipping our high-performance mobile processors to our OEM customers just next month. Now, of course, only Intel provides the scale to ramp a new product family at this speed across all these segments. I think it's just a great example of choice and opportunity and the power of an open, robust ecosystem. All right, so before I show you the advancements we've made in these processors, let me introduce Rajshri Chakubswar, who's here. She's our senior principal engineer, and she's going to show you the magic behind the 12th generation core and why we call this Intel's most significant shift in x86 architecture in more than a decade. Rajshri.
Thank you, GB. With 12th generation Intel Core processors, we are introducing Intel's first performance hybrid architecture with two all-new core microarchitectures, performance cores and efficient core. The performance core, or P-core, is the highest performing CPU Intel has ever built, maximizing single-threaded performance and responsiveness to prioritize for demanding tasks like gaming. The efficient core, or E-core, delivers scalable, multi-threaded performance for modern multitasking, better supporting tasks that can be run in parallel, like image rendering. For these cores to work seamlessly with operating system, we have built a new intelligence directly into hardware called as Intel Thread Director. By carefully monitoring and analyzing in real time, Intel Thread Director guides operating system to place right application threads on right core at right time using hardware telemetry to deliver incredible performance and responsiveness. This is where the real magic happens. Using OS hybrid optimization along with Thread Director feedback, background activities may be efficiently offloaded to E-cores, unlocking massive performance and responsiveness of P-cores for compute-intensive workloads like 4K gaming, 3D design. The 12th generation core processors are Intel's revolutionary approach to x86 architecture. It's dynamic, it's adaptive, and purpose-built for real-world performance.
Well, people can expect to see advancements across this entire product family, including industry-leading connectivity with Wi-Fi 6E and also optional 5G. We also have revolutionary advancements in hardware-based security. And with the broadest ecosystem support, we're talking more than 140 customers across 30 countries. We're developing the choice and the freedom and the open platform that developers and people all around the world deserve. So let's take a look at what you can expect from our brand new 12th generation core desktop processors.
Creativity. When coupled with the right technology, magic happens. Powered by the right tools, creativity takes on new dimensions, can transform rough ideas into genius, has the ability to elevate and inspire. But creators and gamers thrive best without barriers or borders. They shine brightest when they find their flow. No interruptions, no limitations, no compromises. Based on that insight, we created our 12th gen Intel Core processor with 2 core microarchitectures. It is purposeful and adaptive, can handle parallel workloads for greater speed and less downtime, like photo editing, while exporting special effects to complex 3D animations, or 4K gaming and simultaneous streaming with open broadcast software. Featuring the all-new Intel Thread Director, Intel 12th Gen Core can intelligently monitor and analyze, delivering the right workload to the right core, making it all work when and where creators need it most. Intel is making it possible for gamers and creators to stay in the flow, whether that's exploring digital realms or creating new ones. With 12th Gen Core, we are unleashing their creative potential like never before.
So now let's put the processor through the paces and show it off against the competition. I've got Ksenia Chistakova with me today. Hey, Ksenia, what are we looking at today?
Hey, GB. So here I've loaded the same exact photos and videos from a recent adventure I took on these similarly configured systems with the same number of cores and memory configurations. As you can see, both systems are actively exporting in Premiere Pro.
That's right, and on the surface, things to be they look like they're kind of similar, things are the same, but we know underneath the surface that's not the case, right?
Correct, and that becomes very apparent when I use a batch workflow in Adobe Lightroom to process raw 4K images. The system on the left is already starting to fall behind. As for the 12th Gen Core system, we've created a visualizer to show how Intel Thread Director detects the change of application usage and places the Premiere Pro workload onto the E-cores. This allows the system to prioritize the experience and responsiveness of the application I'm focused on right now. And it's this platform technology that allows the 12th Gen Core system to finish this workload 30% faster than the competition.
Wow, 30% faster, that's just fantastic. Thanks, Ksenia, I really appreciate it. Hey, together with our partners, we want to deliver the preeminent platform for creators to create on and for gamers to game on. And that starts today with an exciting announcement from our friends at Dell, and I'm just really pleased to have with me Sam Bird, who's the president of the Client Solutions Group at Dell, and thanks for joining us, Sam. And I think you've got some great news to share with folks, right?
Yeah, hey, thanks for having me, GB. We've got a special occasion. We just celebrated the 25th anniversary of Alienware.
Right.
And hey, with game developers, we've made incredible progress over the past 25 years. You think about gaming today, it's how people relax, play, stay connected, get real. Over 80% of Gen Z and millennials game weekly or daily.
Wow.
So we got some great news today, right in front of us. I'm really excited to announce our new Alienware Aurora R13. It's available today, has 12th gen processors in it.
Wow, and I love it. I love that you came out to launch the system today, coincident with the processor right here on stage at Intel On. It's awesome, and I think, talk a little bit about just the deep co-engineering we've done on this system to make this a fantastic experience.
Yeah, we did a lot of great work together to make this amazing, GB. So we set out to design a system that was an absolute beast, and our co-engineering focused a lot on airflow, and it focused on thermal. So you look at this system today, up to 87% more performance, up to 16% quieter, it runs cooler, you can pack in up to 128 gigabytes of new DDR5 memory, so that's awesome. It has PCI Express 5.0, so all the modders are very happy. And then if you look at this thing, we've put an optional clear side panel on it, EMI shielded, not an easy thing to go and do. 8 RGB lighting zones, so you can not only get performance from it, but it looks amazing.
It's stunning. And so Sam, you want to show off just a little bit about what this thing can do? I know you got to run in a game.
Yeah, it can do some great stuff. So over here, we're running Bannerlord. You can see the performance on Bannerlord is really great. It's what you need from a CPU for an RTS game. And GB, over the weekend, I got to admit, I took a little liberty of, I took a pre-release version of this for a test drive with one of those K-series processors you were just showing off, and I can confirm it runs all the latest AAA gaming titles exceptionally well. Stunning visuals, fluid gameplay, it looks really good.
No, that's great. And we know gamers don't just like to game, they also like to stream, they like to create, and this allows gamers to game and stream this hybrid architecture without compromise, which is why we're just so excited about it. And I know we're just getting started.
Yeah, I loved doing this. It's a great product. I think we have, you said it really well, we're just getting started. I look forward to continuing to push the boundaries with you and breaking through all the limits out there.
Awesome. Thank you very much, Sam. Thanks a
Take
lot.
care.
Good to see you. All right, take
Bye-bye.
care. Okay, hey, before I end my section, I just had one more thing to do. I wanted to have a little bit of fun today. We designed our 12th generation core processors, the desktop, with the community in mind, with the overclocking community in mind in particular. So today, for our final demonstration, I wanted to introduce the #1 ranked overclocker in the world. Alan Glebersuch is here, and he's here with his partner, George Giannopoulos. Hello, gentlemen.
Great to be here.
Thank you for joining us.
No problem.
And just for a little bit of fun, they're going to take the Core i9 12900K CPU on a Z690 motherboard, and we're going to try to break world overclocking world record right here on stage as we sit here. Okay. Now you can see them pouring the liquid nitrogen in as we work. They use the Intel Extreme Tuning capability. Again, gives us the platform of choice, allowing everyone to unlock the power and performance of their processor. And please check out the QR code on your screen for access to that Extreme Tuning utility. It doesn't matter if you're a novice or if you're a pro like these gentlemen. You know, with that capability, we're able to overclock processors, and we have something for everyone. All right, you guys, do you think you're ready to go give it a whirl?
We're going to boot in right now.
All right, here we go. So, now the current record for XTU marks is at 10,021. I just want to see live if they can beat it.
All right, booting in the OS.
Do we need a drum roll? Or
cooling down now.
Oh.
And
do we have a hiccup?
Oh, you know how it goes live.
That's great. Well, listen, I know you guys worked with me yesterday. I'm going to let you keep working.
Sure.
Yesterday, as we did this on stage live, you were able to surpass 12,000 marks and break the world record.
12,500.
In practice, 12,500 yesterday. Yep. And I know you weren't even really trying that hard. So I'm going to let you guys keep going after it if that's okay.
Sure, sounds good.
All right, and with that, hey, Pat, it's back to you.
Hey, thank you so much, Splave. Thank you, the team. We're anxious for that world record. But GB, as you said, you know, our last demo, we can't talk about 12th gen core without also talking about graphics and our Arc Alchemist product line. So Lisa, over to you. Tell us what you have in store.
You're right, Pat. Alchemist is our code name for the first generation of Arc high-performance discrete GPUs, which are being built on TSMC's N6 process. Designed for gamers first, our flagship configuration will feature 32 Xe cores and includes everything required to run the most demanding games, including complete support for DX12 Ultimate. Our hardware support includes ray tracing, mesh shading, variable rate shading, and dedicated matrix engines for AI acceleration, which we call XMX. These engines accelerate a new high-quality and high-performance rendering technique called XeSS, which applies AI to graphics and improves the performance and/or visual experience. XeSS integrates into games and uses motion vectors, prior rendered images, and a fast render of the current frame to generate final high-quality image. We've already done our first few game integrations, and today I'm excited to show you some of the results. This is Riftbreaker, running on an Alchemist GPU. Released earlier this month, Riftbreaker is near the top of Steam's best-selling list. It is also one of our first game integrations for XeSS. The left side is the native game rendered at 1080p, and on the right is XeSS upscaling to 4K. As we zoom in, focus on the wall, and notice how the texture is blurred on the 1080p side. As we dive deeper, the small bugs on the 1080p side blend together, while they're distinct and clear on the XeSS side. In this still image, focus on the bottom of the screen. Notice the ground and the differences between the two sides. It's clear how XeSS upscaling adds detail and clarity to the game. Riftbreaker is just the first of what we expect will be many games taking advantage of the additional performance and quality delivered by XeSS. The application of AI to graphics and gaming is just beginning. Many PC platforms shipping today run on Intel CPUs, providing a great platform for Alchemist, which collaborates closely with other Intel silicon in the system. We call that connection in cooperative computing Deep Link. In this video, I'm showing Deep Link in action. This is Handbrake, a popular video transcoding application. Alchemist on the left, Alchemist with Deep Link on the right. We're showing the Windows Performance Monitor for both systems. Notice on the right how the Deep Link system is fully saturating both the integrated GPU and the discrete Alchemist GPU. And you can see the increase in transcoding speed as you notice the progress bar zipping along on the right side. At this point, the Deep Link system has completed transcoding, while the single GPU system still has work to do. In this example, Deep Link delivers 40% faster transcode. Alchemist Silicon is with our customers and partners right now, and we're excited that it'll be in gamers and creators' hands very soon. It's a big step forward in our XPU journey, and we will deliver the computational horsepower our customers demand in whatever form best suits their application, including more to come on our VPU. Now let me hand it back to you, Pat.
The world record out.
Hey, thanks so much, Lisa. It's clear that devices are still critical, but it's no longer one device per action. Everything is connected. And GB, just in case anybody needed to know if this was alive or not, hey, I remember my first overclocking demo when we broke 1 gigahertz. It failed 5 times the night before, and we finally made it work on stage. This time,
it's the opposite.
It worked 10 times last night, but I want to let everybody know we rebooted the system, already broke the record, and we'll be posting that right after the show today.
Right.
So let's talk about infrastructure and what we need to make all these connected devices happen. You know, the race to zettascale is on to generate, analyze so much data, and we're going to make it available to every human on the planet. You know, it took us 12 years to get from petascale to exascale. What do you think, team? I challenge us to do it in 5.
Well, Pat, actually it took us from petascale to exascale between 2008 to 2021, and here we are just months before we cross over exascale, and the Zeta race has already begun.
Yes, to Zeta and beyond. I got to keep up with my geeky friends here. But we've seen throughout the history of computing that it's swinging on this pendulum from centralized to decentralized, from mainframes and minis to PCs and client-server computing. And now with cloud, it's been swinging back towards centralization.
And then, it's going to be the case for a while that the majority of workloads are going to be inside the data center. That's changing because as we see more and more compute move out towards the edge to be in, whether it's in factories, homes, or shops, some people are predicting that well over half, maybe even 75% of all the data that we produce and analyze will be out at the edge.
Wow. And we know that compute follows data. Right? And as such, we see that pendulum that's been swinging toward cloud, right? It's going to asymptote, and we believe that it's going to be in 2020. In fact, I've looked at it, it's February of 2026, right? We're going to start seeing that we're going to be moving back toward a more decentralized computing model as the edge being the primary growth driver of workloads. Sandra, what do you think?
Well, I think that the important point is that compute, networking, and data are going to be pervasive and growing on the edge, in the data center, and in the cloud. It's actually going to grow everywhere. The intelligence edge, however, is driving massive amounts of growth with increasingly diverse use cases and deployment models, which puts pressure on the underlying infrastructure that we have today. And solving for this requires a vast and connected ecosystem of systems, infrastructure, applications, software, and services. So with computing spreading across all types of heterogeneous fabrics, from CPUs to GPUs, edge devices, interconnect processors, FPGAs, we actually see that persistent memory and software bind all of this together to create a compelling and powerful platform solution, enabling users to execute their workloads on the device and location that best serves their needs.
Yeah, and we're looking at the different software platforms that will be needed in these environments as well as we work with all the cloud service providers to ensure that they benefit regardless of which infrastructure provider you choose. Intel's engagement, for example, in the Cloud Native Computing Foundation is quite broad, with development happening in the Kubernetes ecosystem, the Envoy system, the Istio, and other ecosystems in the open source world that will enable application developers to be productive. Kubernetes, which provides a full platform, which we've adapted with Xeon accelerators and plugins, will enable you to run on our platforms very efficiently with high performance. We also offer Kubernetes operators and container images to help users deploy their workload across their Kubernetes clusters wherever they run, at the cloud, in the data center, to colo at the edge. Over to you, Sandra.
So critical to successful solutions like that is the Intel Xeon Scalable processor family. We shipped our latest 3rd generation Xeon processors, known as Ice Lake, earlier this year. Cloud developers today have broad access to Ice Lake processors within major cloud service providers all around the world. And these include Alibaba, AWS, Baidu, Google, Microsoft, Oracle, and Tencent, just to name a few. And we've worked extensively across an open ecosystem of ISVs, OSVs, and OEMs to ensure developers have optimized services, tools, and software environments to simplify their work. So what comes next? Well, you can expect our next generation processor, codenamed Sapphire Rapids, to deliver new optimized acceleration engines. Designed to tackle overhead in data center scale deployment, these engines will enable greater usage of the performance cores while significantly reducing power and area costs. Of course, the challenge of using dedicated acceleration engines is difficulty with software models, usability, shareability, and memory management. And this is why we're specifically evolving our processors to be easier for developers to build on. Greg's going to join me momentarily to share some of the security tools we've been working on. Sapphire Rapids is going to introduce the Accelerator Interfacing Architecture, or AIA instruction set, which supports sufficient and efficient dispatch, synchronization, and signaling to accelerators and devices from user mode as opposed to high overhead kernel mode. And you can see several other examples of the acceleration engines you'll get with Sapphire Rapids.
Sandra, great stuff. Let's shift gears and drill a bit more into security, which is one of my favorite topics. Cybersecurity threats are keeping pace with every advancement, and the attack surface areas are getting bigger.
Yeah, and Greg, security has never been more important for all of us. And at Intel, security truly is a complete mindset.
And the opportunity to develop layers of hardware-based security combined with software, and the work coming out of research environments and looking at the way we respond to these attack vectors has fueled new levels of collaboration with academic institutions and all of our industry partners. It continuously pushes us to innovate beyond what we thought possible.
And as workloads grow in complexity and move throughout the infrastructure, users and owners of data expect secure, seamless updates, even as their platform grows more complex. Developers require hardware and software tools for confidential computing, including secure enclaves and crypto acceleration to build a strong foundation. Greg, let's talk about some of the security tools that we have.
You bet. I mean, we have many that we've developed at Intel, and I encourage you all to watch our Tech Insight sessions later today to learn more. Let's focus on some of the really key ones right now. First, we have Intel Software Guard Extensions, SGX. It helps define secure enclaves or trusted execution environments that increase the security of application code and can contain significant amounts of data as well. Leveraging SGX allows you to verify that a valid program ran on a valid virtual or physical machine and delivered valid results. So you can perform the most sensitive operations in a trusted execution environment, isolating your application from the operating system itself or even eavesdropping software that happens to be on the system. We're proud that confidential computing, powered by Intel SGX, is the most deployed, most tested, and supported trusted execution environment in the industry. With the latest Xeon Scalable processor family, we pumped up SGX's ability to protect code and data. We're also excited about additional security offerings in the upcoming Sapphire Rapids processor, including updates to Intel's Quick Assist technology, which will deliver a smashing 400 gigabytes per second throughput.
And we're working on new architectural elements to help deploy hardware-isolated virtual machines, which we call Intel Trust Domain Extensions, or TDX. When ready, it'll greatly enhance control of data security and IP protection for the cloud tenant, while helping maintain the cloud provider's role of managing resources and cloud platform integrity. Given the importance of security for all workloads, this capability eases the lift for software developers. In addition to security, predictability is another critical capability required to deliver a seamless hybrid multi-cloud experience. This requires a new intelligent data center architecture, which has major implications on how the software landscape evolves.
Yeah, new applications in the cloud and solutions in the cloud for this new programming and deployment model will be broken down into service-oriented architectures, smaller components that are hosted in their own containers, and a collection of those building up a set of microservices. Each microservice has its own load balancer and in a highly distributed and disaggregated architecture. And one benefit of this approach is better recovery from software crashes or lack of functioning software. For example, when a service or function in a container fails, its workload can be seamlessly redirected to a different container or to a different microservice. If there's a high demand for resources by a single microservice, the system can automatically make appropriate requests to auto-scale the capabilities of that microservice. So you get this dynamic and automatic boosting that's needed to compute, memory, or other resources, which is a key reliability feature for mission-critical applications.
And all of these highly complex, scalable, and high-performing microservices need efficient orchestration. So Nick, how do we make that happen?
So Sandra, that means you're talking about the Infrastructure Processing Unit, or the IPU. So back at Architecture Day in August, we announced 2 new IPU products. There's the FPGA-based IPU, and then the ASIC-based IPU called Mount Evans. I have one right here in my hand. We're finding that cloud service providers increasingly need to secure and protect the software that runs the data center, to protect it from the tenant workloads that they're running inside their servers. So over to you, Pat, to tell us more about it.
There's no better person in the world to have a conversation about IPUs with than Google Fellow and VP of Systems and Systems Services Infrastructure, Amin Vadat. And Amin, it is so good to have you here. And can you tell us a little bit about your job at Google and why you're doing this IPU project with us?
Absolutely, Pat. So really excited to be here. I'm responsible for our entire infrastructure as a service offering at Google for customers across the planet. Google and Intel played a central role in defining what modern warehouse scale computing means 20 years ago, and I'm excited to be here to have a chance to work with you all to do it again.
Well, you know, we have been working together for decades now, but maybe a view of the compute architecture of the data center and what's driving this change?
It's an inflection point, a serious inflection point, and we're seeing a number of trends coming together at the same time. First, the security and isolation posture is not where we need it to be, either within a server or across the servers in the data center. Second, these processors, as we're seeing here today, just keep getting bigger and faster, and we need to make sure that the I/O can keep up with it. Finally, while general purpose computing is going to continue to play a central role in our data centers, we're seeing the rise of machine learning, data analytics, video processing, and more. IPUs are going to play a central role in defining all of these things in the years ahead.
And this is what Mount Evans was all about, right? It was this tearing apart of function on the CPU and really creating this dedicated processor for all of the network traffic and I/O functions that are going on. And this is what we collaborated with you all on.
We worked together from the first day, actually, and I was proud to be part of that team from the beginning. We collaborated in defining a programmable packet processing engine. That's the heart of the IPU. That will serve a whole host of needs, from network function virtualization to service meshes and more, but all going, importantly, at 200 gigabits per second line rate for the next generation of compute infrastructure.
Now, you touched already a little bit, but let's go a bit more on the security aspects of this, because in some ways, I think this may be the most important aspect for a warehouse scale computing capability. So.
The security side is absolutely huge. What the IPU is going to allow us to do, what Mount Evans is going to allow us to do, is strongly delineate management code, the infrastructure code, from the customer code. So the CPU is going to be there entirely for the customer workloads, and we will be able to run our management code on the IPU. In the end, this is going to allow us to support bare metal and really raise the bar for what trustworthy computing means.
Well, that's pretty exciting. Now, as we think about this, we also touched on the workloads, and we're seeing this dramatic shift of next generation workloads with machine learning and AI. How does that change the nature of the data center?
It has been a complete game changer. What we're seeing is that these workloads are insatiable in terms of their I/O needs, in terms of their compute needs, and we're having to spread them across an ever larger number of servers. So these really data-hungry analytics, AI, ML-based workloads, as you said, are going to be the tip of the spear, but they're already huge, and they're going to be taking over essentially what we do.
One last topic is the software architecture, and we're seeing this open, programmable network and P4 and IPDK and the work that we're doing there. Your thoughts in this area?
We're really excited about it, and we're going to be collaborating very closely with Intel to drive the open standards here, both around reliable transport for the data center and beyond, but also P4 as the basis for making sure that this technology goes to a variety of targets, starting with the IPU, but really beyond.
Well, I'm so grateful for the partnership, for the work we did together on the IPU, and now, right, to be able to roll it out to our Intel On audience, and I mean, you've been such a great partner and friend to us. Thank you so very much.
Thank you, Pat. Excited to be here.
Amin is pretty special and just been a great partner and friend. But it also leads us maybe to our next superpower, pervasive connectivity, when everyone and everything is connected. And the network is going soft. As 5G network deployments are underway and as we look forward to 6G, the future lies in a fully programmable network that is truly open and where developers have the freedom to move at the speed of software.
Yeah, that's absolutely right, Pat. By soft, I assume you mean the software, and we see more of the networking infrastructure moving up and out of the hardware into the software. And what we're seeing happen is that developers are bringing their ideas and creating this kind of Cambrian explosion of
Oh, there's a professorial statement.
So what we're really trying to do is, and what's happening over the next few years, is the turning of the keys back over to those who own and operate networks.
So Nick, as a longtime networking software guy myself, you're saying you're going to give me even more power?
That's right.
Thank you.
That's right.
And the idea is that we're going to cloudify the network. And what we did to the data center when it was mainframes and mini computers, and one of Andy Grove's key observations was that we're going to create a horizontal platform, a standard hardware platform. And that's exactly what happened to the server industry at the time. It became horizontal. That was also the building block for the cloud data center that all of us use today. And this is what will enable the network to go soft, that same vertical to horizontal transition.
Making them fixed function, making the network fixed function, it really didn't work out so well. So we're really on a mission to let those who build networks take control to be able to program them for themselves. And we're going to give them the hardware and the software tools to do that. Let me show you how. So I'd like to show you an example of the sorts of things that you can do if you program your network for yourself. So in this demo, I'll be using our new 200 gigabit per second Mount Evans IPU, the one I just showed you, our Tofino switch, and our Xeon scalable processors. Mount Evans is the first in our new line of IPU products. Tofino is one of our programmable switch chips, and later today, we're going to be telling you more about our new P4 programmable 25 terabits per second Tofino 3. So I like to think of the Xeon, the IPU, and the switch. I like to think of them forming an end-to-end programmable platform, a P4 programmable pipeline for all those packets. So let me show you a very common network problem, one that many of you will have encountered before. So the network, your network is dropping packets somewhere along the way. You have no idea where that's happening. All you see is counters incrementing, telling you that something is broken. You have no way to figure out which flow, which application, or which server is causing the problem, or why. See, networking tools are still very rudimentary. We've been using ping and traceroute to debug networks ever since I was a student. And so in a situation like this, we would probably send ping probes along every path, maybe one per second, to see if we can catch the problem. So here's a series of ping probes, and every single one of them is saying that the network is fine, uncongested, and there's no reason for concern. But we know that the network is dropping packets every now and again, and it's driving us crazy. So we need a better way to debug this. So let's step back. What really is the problem? The problem is that the events are so short, our probes miss them. But now, because of all three of these devices are programmable, we can write a program to tag every packet with information about the network state. And we can find out which path our packets took, how long it waited at every hop along the way, and even who it shared the queues with. And we do this by simply writing a short program to run in the IPUs and in the switches. And then we can decide if the program is running all the time or only when we encounter a problem. It's a program. It's up to us. So to make things more interesting, we're going to monitor this network here with 5 switches and 2 IPUs that are connecting 2 Xeon endpoints. OK, so now we can begin to see the problem. Every few seconds, 2 or more synchronized applications are causing a microburst. This is a small burst of congestion that lasts just 20 microseconds. Now, we'd have to send about 50,000 probes every second if we wanted to catch this in the old way. But because we've asked the network to tell us the problem directly when it happens, it's super clear where the problem lies. So this example here shows a 20 microsecond microburst, but what's even more remarkable, that these devices can capture an event lasting just 1 nanosecond. In other words, 1 billion times more precise than the 1 second ping probes we were sending earlier. This technique, we call it in-band network telemetry, and we've now seen many cloud operators and financial networks use this technique to capture every congestion event in their network and then track down the root cause. And at the end of the day, it's just a program. What's more, because all P4 programs run at line rate, these 100 gigabit per second links, they're running at exactly the same speed as they did before when they were fixed function devices. So even though devices are fully programmable, they can run at the same performance as those fixed function devices that they're going to replace. And you can program these devices to do pretty much anything you want. We've seen cloud service providers build on top of this fine-grained measurement to create new load balancing and congestion control algorithms for their networks. It's really up to the network developer to decide what they want to do with it. And we're constantly surprised and amazed by the creative new processing ideas that they put into their network pipeline. So what you saw here was a simple demonstration of measurement and monitoring built on top of in-band network telemetry. Our Deep Insight software shown here is available as a self-contained tool running in the cloud, or as a set of libraries to let you analyze the telemetry data and identify the root cause of your network problems. So now let's move to the edge of the network. It's changing too, really fast. So with more computing taking place in colo facilities, internet exchanges, central offices, and even at the base of a radio mast, computation at the edge has a faster and lower communication path out to the end user, that's us, which means we can now move the compute workloads that run the network into software running at the edge. In fact, fixed function hardware for things like VPNs, firewalls, and in fact now the entire radio access network is being replaced by network software. And that's running out at the edge, which in turn means we can manage it and orchestrate it from the cloud. In recent years, we've added new instructions and accelerators to our Xeon processors to allow them to run these new web network workloads. We offer Xeon processors today, but we're also investing heavily in our next generation Xeon D processors. These are for compute needed in some of the really dense, power-constrained environments, such as the foot of a radio mast or in a crowded central office. These devices are so powerful that you can turn them into high-performance security appliances or AI inference platforms. And you can even use them to implement an entire radio access network in software. And we call this technique Virtual RAN, or vRAN for short. Many of the new 5G networks that are being built today, they use vRAN to separate the complex network functions that they can put in software from the underlying hardware. And it's another example of the network infrastructure moving up and out of hardware into software, where it can evolve much, much faster. So Intel's FlexRAN software is the first software to exploit the full power of Xeon, allowing wireless access workloads to run entirely in software. Intel is also very active in the O-RAN Alliance, collaborating to create open specs, open APIs to exploit this full power of FlexRAN. And this is a perfect time to introduce a very special guest. So AT&T has been one of the pioneers in moving the network to software through network virtualization. And so it's a great pleasure today to be joined by Andre Fuich, who is president of AT&T Labs and AT&T's chief technology officer. So Andre has been a real leading pioneer in making networks software defined. So he chairs the Open Networking Foundation, the O-RAN Alliance, and he's led many of AT&T's work to move workloads off fixed function boxes and into software. Welcome, Andre.
Great to be here, Nick.
Great to have you here. So to begin with, perhaps you can tell us a little bit about this journey that you've been on at AT&T to move these workloads into the virtual RAN.
Absolutely. So we at AT&T started off on this big journey about 6-7 years ago to really virtualize many of our network functions and take advantage of software-defined networking. And in fact, I'm proud to say that just in the last year, over 75% of our network is fully virtualized. And this is really a testament not just to great technology, but great technologists to make this happen. And a lot of this has happened really as a foundation on top of a lot of Intel's great products, such as the Xeon server line.
That's super, super. So as you see this moving out in a sort of a transition from 5G and then out to 6G, how is that going to go? How is that going to roll out?
Yeah, so whenever we're evolving from one generation to the next in the radio access network, it's never just a big rip and replace flash cut. It's always an evolution. And of course, AT&T, we just purchased a lot of new mid-band spectrum. And as we're lighting up that new spectrum over the next several years, we see vRAN being a really important part, not just to get us more economies of scale, but also better performance. And what's really exciting to us is actually to open this up to allow more software development, more programmability into the network. And we think that's where the next new generation of exciting services are going to come from.
That's fantastic. So, you know, Intel and AT&T, we've been working together on this for a number of years now. And, you know, we see you as a developer. This whole event here is about the developer. You are that developer. Your engineers are developing on these platforms. So what can we do that would be better? How can we work better together? And what do you expect from us in the future?
Well, certainly it always starts with silicon, and that's really important with the hardware and acceleration that's going on. But really where we want to see more is in software, and also not just in the software architecture such as FlexRAN, but really the ecosystem of developers. We want to see more innovation come in, and we believe that moving more to software lowers some of those entry barriers to let more developers in, to create some of these new and exciting services, to really connect not just the hundreds of millions of connections we have today, but billions over the next decade.
Super exciting. I'm really, really glad that you could be here today. Thank you so much.
Thanks for having me.
So, and to our audience, as you can see, this is a really exciting time to develop for vRAN as leading operators around the world plan their next large-scale deployments. So let's change gears and let's focus on AI inference and how we're doing that at the edge. So Intel is coming up with and developing a number of platforms. We have Smart Edge that allows our customers and their customers to develop new AI inference applications. And we have OpenVINO, which is seeing thousands of deployments that we're going to be hearing more about in a few minutes. And our goal is to create an ecosystem of trusted global vendors so that their customers can come to them, specify and work on new edge inference applications and have them produce them for them.
Well, our Intel Dev Cloud, which you mentioned before, makes you more productive when you're deciding on the right hardware for optimal AI application performance. And Dev Cloud for the Edge provides instant feedback via our virtual AI prototyping tool that you can get access to make progress on your models at the edge.
And Greg, with the explosion of all the data, we have to create software that empowers developers to derive the most intelligence from their data. So OpenVINO has enabled hundreds of thousands of developers to dramatically increase and accelerate AI inferencing performance since its introduction in 2018. And we're about to ship OpenVINO 2022.1, which includes 3.5 years of developer feedback rolled into the API improvements.
Super exciting.
Wow. That's great. So we're writing the software to leverage all these various types of silicon and getting you ready now for what comes next. So jump in and join us.
Hey, Greg, Nick, did you guys order something from FedEx?
What do we got here? Hey, So this is FedEx's same-day delivery bot. And we've been working with FedEx to produce a much lower power than their alternative. And we're super glad to be part of this very efficient delivery platform.
So let's see the video.
Okay, let's see the video and learn more about it.
For more than 30 years, I and my small team of engineers here have been working on developing mobility technologies to help people live a better life. Recently, we've been able to work with two icons of American industry, global industry, FedEx and Intel. We are developing the Roxo last mile delivery robot for FedEx using Intel as a core piece of the technology to make that possible. There's even more incredible things that we intend to do as we develop these technologies. And we're hoping that if you have a passion for solving real problems to make the world a better place, you'll give us a call and join in our efforts.
Hi, I'm David Casson, Vice President of Same-Day Transportation for FedEx. We've invented Roxo, the same-day delivery bot. This bot is intended to serve the last-mile delivery for the exploding e-commerce space. Roxo can do many things. It's got autonomous software that allows it to travel on the side of the road, on the sidewalk. It can even climb curbs and go to the last 50 feet and the doorstep of a customer. Roxo has highly sophisticated autonomous software and hardware that could not have been possible without the great partnership between DECA and Intel. Thank you for having Roxo today, and enjoy the rest of the conference.
Thank you, Dean and David. And let me tell you a little bit about the great technology that's inside this robot. Roxo uses our Tiger Lake processor, One API software technology, and other technologies to help drive this as a solution. Well, Roxo, I'm sure you got some more deliveries to make, and bring me a pizza after the event.
Well, we're definitely in the realm of AI now. And you know, machines will soon be making more decisions than humans do. And our role as humans is to make sure these decisions are better and ethical.
Yeah, Pat, AI is making more and more human tasks that used to be difficult or impossible with computing now possible. And our role at Intel is to ensure that we responsibly scale this capability to developers everywhere. Actually, we've made AI much more scalable through more than 5 years of extensive optimizations for popular industry libraries, frameworks, and low-code or no-code developer tools. These optimizations span the entire ingest to inference pipeline. And by offering the only x86 processors, Xeon and Core, that have built-in AI acceleration, we are actually making AI available to everyone. It's the AI you need on the CPU you have. And there's lots and lots of use cases, all different types of deployments, all different locations that we'd like to maybe share a few examples from. So first, let me talk about Alibaba and the work we've been doing with them in partnering to build an end-to-end toolkit called DeepRec. DeepRec facilitates deep learning, training, and deployment of recommendation systems, a workload which consumes many of the compute AI cycles in a data center. And with the diversity of compute, network, bandwidth, and memory requirements, we actually see that having AI in your CPU makes AI workloads accessible to everyone. Today, Alibaba uses Intel Xeon processors across their internal business applications and then their external Alibaba Cloud, and specifically on their Weibo application, which is a Twitter-like service in China.
DeepRec is powered by, no surprise, One API, in particular our advanced vector extensions, AVX, our vector neural network instructions, and we use the BF16 precision for acceleration, resulting in up to 7 times gains. Developers can easily load and update models, process embedding layers, leverage existing model zoos, and deploy extremely large-scale recommender system services with trillions of samples. We've made AI more productive through our extensive optimizations in our toolkits and libraries that make it easier to run AI everywhere. For example, we've made it easy to add AI to existing Spark and Hadoop platforms for big data analytics with our Big DL technology. Big DL seamlessly scales AI models to big data clusters with thousands of nodes for distributed training or inference, and customers like MasterCard, Burger King, Office Depot, and over 30 other customers are using this technology today.
In fact, MasterCard has trained and deployed deep learning systems and models to help identify and increase revenue opportunities with up to 1.6 billion of their own customers. They used our Big DL toolkit to deploy a large-scale, end-to-end distributed deep learning solution on top of their existing Xeon Spark clusters. And with Intel's Gaudi now deployed at AWS, which was launched and announced yesterday,
Congratulations.
we see that Gaudi can really help in the places where you need intense deep learning processing capabilities. So we're very proud and very excited to make that available to developers everywhere.
There are really 3 core steps to every AI developer to work through. First is your data pre-processing or data wrangling, then your model development, model training, and then deployment. Let's break each one down. For the data processing side, we found that adding capabilities into PyData through the PyData API consortium which aims to defragment the pre-processing space after its rapid growth and popularity and proliferation of different data frame libraries. We've enabled Modin, an open source library that accelerates Pandas data frames, the most popular data processing library, by up to 20x with one-line code change to scale to the cloud.
And for the second step, modeling, scikit-learn is the most popular machine learning library, and Intel's optimizations enable up to a 100 times speed up with the same one-line code change to enable developers everywhere. And with TensorFlow, which is the most popular deep learning framework, we've actually partnered with Google to enable Intel optimizations in the main distribution and co-architected a new mechanism to seamlessly support multiple AI hardware accelerators. Also, we're optimizing to support upcoming AMX for Sapphire Rapids and Intel GPUs. So similarly, Intel's partnered with other cloud service providers, Facebook, Amazon, Microsoft, and Baidu to accelerate PyTorch, MXNet, OnyxNet runtime, and Paddle on Intel Xeon processors. So now every Xeon processor will accelerate AI out of the box with the most popular developer software, truly bringing AI to everyone.
Hey, and by the way, in Q3, we had over 8 million downloads of that Intel-enhanced TensorFlow software by the community.
Wow.
So the final step in deployment, with the Intel Neural Compressor, which does quantization, it can reduce the time from days to minutes for data scientists to prune and quantize their deep learning models for inference deployment at the cloud, in the data center, at the edge. For ML engineers and app developers looking for standalone tool-optimized pre-trained models, OpenVINO, which we've mentioned, automatically prunes and quantizes applications for computer vision, natural language processing across a broad range of use cases. We're also helping make all the piece parts in one ML workflow together with Converge.io, one of the latest and fastest growing MLOps platforms. Converge.io orchestrates a wide variety of tools and infrastructures, including on the cloud, on-prem, in the private cloud, in colos, wherever you want to deploy any, including the edge. Tell us more, Sandra.
Well, hello, John. Let's take a look at a few of these optimizations and how they combine to take AI to a whole new level for developers.
Great. Here, we're showing how easy it is to use the Intel Neural Compressor, which is an open source Python library to help developers quickly deploy low precision inference solutions on popular deep learning frameworks such as TensorFlow. Out of the box, developers can run AI on Intel CPUs literally in minutes using a simple GUI as opposed to our competitor solutions where developers spend time manually writing and optimizing code. In fact, developers spend time using Ink can increase their productivity by up to 18x versus TensorRT when quantizing models from FP32 to int8 numerical formats.
So how do these optimizations actually impact performance, John?
Here we're looking at the deep learning workload, SSD ResNet 34, a popular object detection topology running on our 3rd gen Intel Xeon scalable processors. And it's running stock TensorFlow. You can see that the baseline inference throughput here is about 13 images per second. As Greg noted earlier, TensorFlow now has native OneAPI deep neural network library optimizations, which lead to about a 1.5x speed up over our baseline. Next, Ink, which automatically prunes and quantizes trained models from FP32 to int8, takes advantage of Intel DL Boost on our 3rd gen Xeon scalable processors to deliver an additional 3.9x speed up.
So these performance improvements are great, and I want to see what we can do on Sapphire Rapids with AMX instructions.
Great, let's run those numbers now. As you can see, with Sapphire Rapids, we're getting an additional 4.8x speed up with AMX.
Okay, so then that's a a total of 30 times total AI performance gain in one generation with these hardware and software optimizations. Do I have that right?
That's right. And to put our pre-production CPU performance into further perspective, we also benchmarked Sapphire Rapids versus GPU on ResNet 50, which is the popular image recognition topology. As you can see, our dual socket server with the next gen general purpose CPU can infer over 24,000 images per second compared to 16,000 images per second with the NVIDIA A30 GPU. This means we can deliver better than 1.5x the performance of NVIDIA's mainstream inferencing GPU for 2022. And don't forget that the A30 GPU still needs a host CPU to function.
Well, the bottom line is that today, so many customers are able to deliver the AI performance they need inside the applications they're running on Xeon processors, thanks to the built-in AI acceleration and extensive software optimizations. And with Sapphire Rapids coming soon, and with more AI, it'll be possible for us to do even more and really not need the expensive proprietary power-consuming discrete accelerators that are in the market today. So, one of the things that we know, John, is that there's no one-size-fits-all compute for AI, and there are customers and usage environments where there's so much dedicated deep learning that acceleration may make sense. So another great example is our work with European chip designer Cypril. Cypril is designing an indigenous microprocessor that will be used in European exascale supercomputers, and they've selected Intel's Ponte Vecchio GPU as the HPC accelerator within the system's high-performance compute node. To tie the two computing environments together, Cypril is developing on one API as a unified software specification to increase developer productivity and workload performance. And we see great potential in our work with Cypril as Intel executes on our IDM 2.0 strategy and brings leading-edge foundry services to our European customers. It's really exciting to see how our strategy is coming full circle. Pat, let's check out some of the future technologies and innovations that our Intel's Labs is working on today.
Neuromorphic computing is a fundamental rethinking of computer architecture, inspired by the form and function of the brain's neural circuitry. In Intel Labs, we're applying these biological principles to achieve huge gains in processing speed and efficiency. Our new Loihi 2 chip is fabbed with a pre-production version of our Intel 4 process. Compared to our first generation, Loihi 2 boosts the neural capacity by 8 times in a chip that's half the size with greatly expanded programmability. We've also launched Lava as an open source project to encourage convergence at the software level so everyone in this field can move faster to commercial applications. Loihi 2 and Lava are going to build on this foundation to demonstrate new AI capabilities in the computers, sensors, robots, and vehicles that are emerging from the lab and will eventually transform computing as we know it.
Our quantum device, or qubit, is built on 50 years of Intel's transistor technology. This is the same 300 millimeter fabrication facility where we make our advanced transistor devices. In this lab, we're using our Horse Ridge 2 cryogenic control technology to manipulate a single electron that resides in a sea of about 50,000 silicon atoms. And we manipulate that single electron between spin up and spin down.
We're really focusing on research at every level of the quantum computing stack. So that includes the Intel Quantum Compiler, Intel Quantum Runtime, Intel Qubit Control Processor, as well as the hardware. We've developed a developer stack. Right now it's in an alpha version and we're sharing it with close partners. With Intel's research approach to scalability at every layer of the computational stack, we are on the path to quantum practicality.
Quantum computing, neuromorphic computing, advanced AI. We have so much good stuff going on in Intel Labs. We look forward to telling you about them in the future. But one of them, specifically around AI, we have to think about the governance that guides this journey as we bring this technology into broad existence in humanity. Because technology must consistently demonstrate its outcomes are superior to human results. Then it can become standard and accepted. We can't let ourselves blindly follow economic or algorithmic innovations that can run amok. When you create something, ask yourself, have I made society better or worse? What does this look like in reality? Well, Mobilize RSS, Responsibility, Sensitive Safety, is a framework that measures the performance of autonomous vehicles and ensures that they successfully implement legal and assurance frameworks and smoothly integrate with human drivers on the road. RSS formalizes human notions of safe driving using mathematical formulas and logical rules that are transparent and verifiable. This is what we have to do broadly. Technology is a human creation that allows us to define what is possible. And I believe the superpowers can bring humanity together. The question is no longer if something can be done, but why are we doing this? Technology, as we see, is inherently neutral. It's up to us to shape it in a way that is more responsible, inclusive, sustainable, enabling, and ethical.
Acute myeloid leukemia is an aggressive cancer with no known warning signs, so early detection is very hard, if not impossible. In 2018, my grandfather was diagnosed with it and died a year later. I was convinced that there must have been signs that were missed in my grandfather's blood test before he was diagnosed, and I wanted to use my knowledge in AI to try and make a difference. I began to imagine an open source program that the community could all work together on, sharing information and finding solutions upon. We need to make partnerships with the hospitals and research centres to get access to the data and the skills that can help us move forward in our mission. If we can work together, we can be the difference.
Of course, electrical engineering is just for boys.
So I took up electrical engineering, and that's where my story starts. It wasn't only the math or the science that interested me, it was the problem-solving aspect. While testing for arsenic in water for my PhD in computer science, it suddenly clicked. Technology can help bridge the gap between simply monitoring a problem and actually solving it. Setting up NextLeaf Analytics was my way of having a direct impact to change the system. When we started monitoring the temperature of fridges more than a decade ago, we never could have imagined the scale and speed of global distribution needed for the heat-sensitive COVID vaccine. Utilizing NextLeaf's experience with temperature monitoring and analytical data, we've developed portable sensors to monitor the temperature of the vaccines during transportation and are working closely with ministries of health to establish responsive supply chains that get the vaccines into arms effectively and equitably. Turns out, girls can do electrical engineering. Who would have thought?
Wow, and we're still at the beginning of innovation in AI. Together, we're going to continue to push the envelope. And speaking of pushing the envelope, we previously announced a collaboration with Argonne National Laboratory, a leading research institution in the US, co-designed the Aurora system. And Aurora is advancing scientific computing with the convergence of HPC, or high-performance computing, data and analytics, and AI, all built on an Intel architecture. And we've been working on this technology over the last decade to bring exascale computing to reality. Today, I'm pleased to say that we're not going to do one exaflop, but we're going to deliver 2 exaflops of peak compute performance, overachieving yet again. Let's hear from Argonne National Labs, Paul and Rick, right now.
Thanks, Pat. We're excited to be with Intel today to discuss the great possibilities of Aurora and its cutting-edge capabilities. Its construction is well underway, and we look forward to launching the installation this year. Thanks to the steadfast support of the U.S. Department of Energy, Argonne and its partners are leading in the development of some of the world's premier supercomputers. Our scientists and engineers continue to open new frontiers for America's exascale future. We are empowering pivotal discoveries and transformative innovations to ensure leadership in scientific computing. Together, we are accelerating the science and technology that drive U.S. prosperity and security.
That's right, Paul. Some of the key research areas for Aurora include climate modeling to understand the impacts of climate change, discovering new materials for green energy, therapeutics development for cancer and COVID, and more generally, advancing AI for scientific discovery. Aurora will also offer the scientific community the compute power for the most advanced research in fields such as biochemistry, engineering, cosmology, and energy technologies. Computing resources through Argonne's Leadership Computing Facility are available to researchers from universities, industry, and government agencies. Through a substantial allocation of computing time and user support services, we enable large-scale projects aimed at solving some of the world's largest and most complex problems in science and engineering. As a final note, Argonne is always looking for a wide range of researchers and students. We're dedicated to creating a more diverse developer community to drive forward on HPC and AI.
Thanks, Paul. Rick, I can't think of a more exciting note to wrap our time up with today. Developers, you are the true heroes of the digitized world. And I hope we've given you a lot to think about and a lot to work on regarding the not-so-secret superpowers. Stay tuned for more of Innovation 2021. Thank you so very much.